What's that?
But I hope that was the answer.
I forgot to press record. I could send you the YouTube link of that. I think it's Jack Black singing too, so it's not, you know, the greatest. Anyway, so here we go. Standard form. When you're dealing with standard form of equation, when we go to graph these things, there are some very simple steps to take. Don't hoard all the graph paper this time. All you need is 2 of them. When you go to graph anything that's in standard form, I'm going to work with a very simple setup. Y equals 2x squared minus 6x, or minus 12x plus 6. I don't know. Just making stuff up. Let's say I have that quadratic equation. All right. Now, when I go to graph these things, there's a few rules that you may or may not remember. This is in standard form. I have coefficients a, b, and c, 2, negative 12, and 6 correspond, or respectively. And when I go to graph something like this, the very first thing I want to identify is what's called my axis of symmetry. Before I even get this far, I think I neglected the fact of what every quadratic function looks like. What does it look like? It's a parabola. Yeah, I kind of went the parabola. All these quadratics all look like up like a cup or down like a frown.
Not even sideways?
No, that's a hyperbola. Or one of those. So, as we get into this stuff, guys, come on. As we get into this stuff, the first thing you want to do is identify what's called the axis of symmetry. The axis of symmetry takes the parabola and basically cuts it in half. So that way the parabola can fold in on itself. Parabola. P-A-R-A, bola. P-A-R-A, bola. I think there's only one L.
There's a silent H in there.
Every single axis of symmetry always starts the same because it's a vertical line. Since our parabolas are up like a cup or down like a frown, in order to cut it in half, it has to be a line that goes up and down. So it's always going to be x equals something. Well, that x equaling something is always going to be the opposite of b divided by 2 times a. Every single time. In the example that I have here, the opposite of b, well, b is negative 12. The opposite of negative 12 would be 12. So in my example, it's 12 divided by 2 times 2, otherwise known as 12 divided by 4, which is 3. So that means my axis of symmetry is the vertical line x equals 3. Now this should have been the first step you guys did back in Algebra 1 as well when you were solving these things out, going to plot them. You always find your axis of symmetry first. So what I do is, my axis of symmetry is always going to be a dotted line because that line is really not part of the curve. It's just used to help plot points off the curve. So your axis of symmetry will always be a dotted line.
Is that the hidden line?
Yes. Okay. And once you get that part, the vertex of every parabola lies on the axis of symmetry. Now, what we have to be able to identify now is when you're working with the vertex is that x equals a number, whatever it may be, in this case our axis of symmetry, that will always be the x coordinate for the vertex. Because your vertex lies on the axis of symmetry, so your x coordinate for your vertex will always be that x value. Well, how do you figure out your y value? You just substitute it in. So the example I have up here, we have 2 times x squared minus 12 times x plus 6. So if I substitute in 3, we get 2 times 9 minus 12 times 3 plus 6. 18, 24, minus 24, or minus 36, so it's negative 12. So my vertex is at 3 comma negative 12. Is that vertex open up, or does it open up, or does it open down? Remember that? Does it open upward, or does it open downward? What's the value of A? Is it positive or negative? So it's going to be opening upward. In order to tell if this opens upward or downward, if A is positive, it opens upward. If A is negative, it opens downward. That's all in this case, all we're worried about is what's the value of A. Now, is that vertex a maximum or a minimum value of the parabola? Yes, sir.
Did you just twirl your pencil in your hand?
Probably.
That was really cool.
I didn't realize I did that. Yes.
With A is 0.
Then you won't have a quadratic, because then you'll have a linear function, because it won't be x squared.
Oh,
Yes.
A is negative, it opens up.
Down.
Down.
Down, okay.
Yeah. So here's what we wind up with. You've got your function, you've got your axis of symmetry is always x equals the opposite of b over 2a. It opens upwards, and the vertex is a minimum if a is positive. It opens downward, and your vertex is now a maximum if a is negative.
Because then it's the top.
Correct.
Even.
Yep. So now I know that I have a vertex at 3, negative 12, axis of symmetry at x equals 3, and I know it's opening upward. So what we have to do now is identify some very simple symmetric twins. Girl.
It's not even me from Bill. It's so funny.
What I mean by symmetric twins, when you have an axis of symmetry, it's taking every point on the parabola that has a matching point on the other side. So if I pick a point that's very easy to work with, 0. How many spots is 0 to the left of our vertex? Okay. If I substitute in 0 for x, what's my value for y? 6. At 0, it's 6. Okay? It's opening upward. All I'm doing is just substituting in. Now, since 0 is 3 spots away from the axis of symmetry, 3 spots the other direction should also be a value of 6. That's what you would consider a symmetric twin. Those 2 points are equidistant from the axis of symmetry. Now, there's other sets of symmetric twins in here as well. All we have to do is just find them. Pick another number. 4. Substitute in. Or better yet, there's a button on your calculator that says table. Go to your calculator. Y equals
I'm not sure.
2x squared
2.
minus 12x.
Which one's the x button again?
That's the one next to alpha.
The x ton.
Plus 6. From here, all we have to do is go right to your table. Oops, that didn't write the button. Second graph.
Wow.
Did you just do that at the beginning, like before you even do the 0?
You can. I'm just showing you where we get at here. Now, we all know that the axis of symmetry lies where? When x equals what? 3. Did you guys know that you can move up and down on the table?
Yeah.
What I would recommend you do, because from here you've got, 7 values of x shown. Put the axis of symmetry right in the middle.
So put the 3 right
And here's why I'm saying if you do that.
Put the 3 right
if I'm putting that, let me just move this up so you can see this, what I'm talking about. If I put the 3 in the middle of for my axis of symmetry, what happens here, here is my axis of symmetry, okay? 2 and 4 are equidistant from 3. 1 and 5 are equidistant from 3. These guys are showing you sets of symmetric twins. 5 has the same y value, -4, 1, -4. They're telling you the ordered pairs that are being created. They're equidistant from here and here. It's just an easy way to get symmetric twins. So at 1 it was -4. It kind of does. In the symmetric twin thing, it just so happens with the numbers the way it looked like, that's all. So now what we've done is we've created our parabola just by plotting the symmetric twins, getting the axis of symmetry and going for it. Okay? So when we're working with standard form, it's kind of the same thing you guys saw back in Algebra 1. Remember, first thing you want to do is always, always, always find that axis of symmetry. Figure out what your vertex is. Label it as, either as a maximum or minimum. Is it up like a cup or down like a frown? And then plot some symmetric twins. Yeah. Alex.
Without a calculator, how would you find it?
You have to substitute in, which
So
means
that's
you'll.
what I thought that. That's what I was thinking about it.
Which means at some point in time you'll have to do this by hand too.
What? That sounds awful.
So you're just one step ahead of us all.
Well, I'm still using my hand to type it.
Let's look at another form. Yes, sir.
Could it be my hypotenuse that there might be a calculator and non-calculated portion?
Are you a right triangle?
You got the joke. Good but,
Hypothesis.
hypothesis.
I figured as much.
Would that be right?
Probably. Let's look at the other forms. The other ones you're not accustomed to seeing yet.
Is other forms?
Yeah. I think the other forms are easier to use. I honestly believe that vertex form is easier than standard form. There's less work involved. That would make you happy. You'll have to know the 3 forms.
I think Alex K. A, H, and K. I like those.
A, H, and K. Once again, like we talked about for the first time with A, H, and K with absolute value graphs, if you recall. We said that you're going to see them in quadratics. You're going to see them in, you're going to see them with square roots. You're going to see them with exponential. You're going to see them in everything we graph. There's always going to be an A, H, and K. And A, H, and K always mean the same thing. A tells you if it's opening upward or downward. So if A is positive, it opens up. If A is negative, it opens down. H and K is always going to be your center. Remember, H, horizontal, left and right. K, vertical, up and down. It's your Y value. Okay? So if I want to look at it as a very simple example of this one, if I say Y equals -2, X plus 4, quantity squared, minus 2. Watch out from the floor there, it jumps out at you. There's another line there. In this case, just by looking at this, we know if this is going to be opening upward or downward.
It's going to be downward.
It's going to open downward. I know right away, since my A value is negative, I know it's going to be opening down, so my vertex is going to be a maximum. I know I'm going to have a maximum right away. I also can identify my center.
4, -2.
Is it 4, -2, or -4, +2, or is it -4 and -2?
I would say it's 4, -2.
Remember, when you guys dealt with H's and K's, remember how every time the H value was always the opposite, the K value was the same? Still holds true.
So that's negative.
This is because in order to look like X minus H, it would have been X minus a -4.
Keep change.
So what is it then?
It's going to be H is -4 and K is -2. So where is your vertex located? What is your axis of symmetry? What's your x-coordinate for your vertex?
-4.
-4. So right away, just taking that information from, I always forget this, vertex form, it tends to be a lot easier to graph. So let's look at a graph. So let's see. I have the axis of symmetry at x equals -4. I have the vertex at -4 and -2. I know that's the maximum value, which means it's got to be opening downward. Will this function have any zeros? No, it doesn't cross the x-axis, so I will not have any zeros. So all I need now is to figure out some symmetric twins. There are two ways of going about that. You could substitute in values to the left and to the right of the axis of symmetry, or table function on your calculator. Once again, go back to your calculator. We have y equals, clear it out, it was -2 parentheses x plus 4 quantity squared minus 2, and go to your table. And what value should I center on my table? Probably right, because -4 is my axis of symmetry. That means every value, one value above -4, one value below -4 are symmetric twins. So what I'm doing here, just by manipulating my calculator, I'm getting symmetric twins visible to myself without having to do my substitution, do all that substitution. You can do substitution all you want. It's kind of a waste of time. You have a calculator. Axis of symmetry is at x equals -4. One point to the left of that is -5. That ordered pair is -5, -4. One spot over here, -6, -10. And there's your parabola. And that's all you got to do. Do you see how using using vertex form tends to be a little bit easier to work with?
Yeah.
Yes?
Can you explain how to find whether it goes up or down on the vertex form?
A. It always works with A. If A is positive for any of these three forms, it moves up. If A is negative, it goes down.
Okay.
Okay? It works, and that's the same standard. It's basically the same idea for every single graph we have. If A is positive, it's moving the up direction. If A is negative, it's always moving the negative direction. You'll see that when we get to cube roots and square roots and stuff like that as well. Yes, sir?
Doesn't your table basically dictate though whether it goes up or down?
Yeah, but if you already know, as long as you know from the function itself, when you're looking at it, that way if you typed in something incorrectly, yeah.
So why is he such a fool? Yeah, Jim, so much
So I was, did you hear his laugh?
Yeah.
No, and I don't care.
You know what they look.
Now, let's look at intercept form, because that's the last one. That one tends to be a little bit trickier for most students to work with. I wanted to spend a little bit more time on intercept form. Okay? What?
Yeah, they're in a grow up. Maybe second grade, at least. I guess.
Intercept form.
Is this like sloping or pointing?
Intercept form uses factored versions of standard form. When we had to factor stuff in the past, you would take what times what, in this example I have on the board here, what times what's -12, add together to get +1. You would factor it out to be x plus 4, x minus 3. Yeah, Archie, we're doing that tomorrow. and probably Monday, and bits of Tuesday at the beginning. So you
Maybe
got it.
solid
Factoring is something that takes a lot of stuff to do in math. We do lots of factoring. What these intercepts are giving you is from intercept form, you're able to identify the zeros of the function right away. Now, the example I wrote over on the board on that side is that I had y equals x plus 4, x minus 3. Now, if you were back in Algebra 1 and you were asked to find the zeros of that, you would take the following two terms, set them equal to 0, and you would be finding out where it crosses the x-axis. So the zeros of x plus 3, x minus 3 are at negative 4 and positive 3. So you have a 0 at negative 4 and positive 3. When you were factoring, when you found zeros while you were factoring, you were figuring out where the parabola, where the graph of this quadratic was crossing the x-axis. What intercept form is doing is that it's giving you a factored quadratic to start with, and all you have to do is identify your zeros. So if they give you x plus 3, x minus 3, remember, or x plus 4, x minus 3, your 0 is always the opposite sign. What makes this 0? What makes x plus 4 equal to 0? Well, negative 4 plus 4 is 0. What makes x minus 3 equal to 0? 3 minus 3 is 0. So when you go to plot those, that's where you cross the x-axis. Negative 4, positive 3. Will this one open upward or downward?
It would open upward.
Why?
Because it's 1.
Good, A is 1. Since you don't see a distinguished value of A, not like prim and proper, distinguished, as in like shown, math humor. Since A really isn't there, it's always going to be 1. And it's assumed to be a positive 1. So this one will open upward. So will my vertex be a maximum or a minimum if it's opening upward?
No, minimum. Max.
So we have a minimum. Now, in order to figure out what your axis of symmetry is you have to remember what it means to be symmetric twins. Those zeros are symmetric twins. Those 2 points are equidistant to that axis of symmetry. So if these two guys have to be equidistant to it, doesn't the axis of symmetry have to line up halfway between them?
Yeah.
All right, what's negative 4 plus 3?
Oh,
Cut it in half. What you do when you have intercept form is you find the average of them. When you're finding the average, you're finding the halfway point. You're finding the midpoint, basically. So that means your axis of symmetry occurred at the line x equals negative 1. So it's a dotted line
I respect that.
right there. They're both, what, 3.5 spots away from the axis of symmetry. Now we have to figure out what the vertex is. Once again, all you have to do is substitute in. I know that my vertex is going to occur at negative 1/2 comma something. Well, negative 1/2 plus 4 times negative 1/2 minus 3. Your calculator will do that. Negative 1/2 plus 4, negative 1/2 minus 3. When I'm typing it in my calculator a lot of times, it's a little bit easier to use the decimal value just because it takes less time. Hit enter. And then what do you do? What do you type? Or do you know what 12 1/4 looks like? 12.25? Could you do? Oh, negative 49/4. Now, okay, we're graphing this. Could you write negative 12 1/4?
Illegal.
It's okay. It's no big deal. This is one of those. Could you write that? Because in the grand scheme of things, if you understand it's negative 12 and a quarter, do you have to write down that it's negative 49/4? Mixed numbers suck. Yes, I do not like mixed numbers. But if I'm plotting this, can I just say it's about right here for right now?
My dad got a about that.
Okay? It's one of those things as you go through here. Remember, I just made up that example off the top of my head. It wasn't the cleanest. They're not always going to be the cleanest. Sometimes they are kind of messy like that. Now remember, is this one opening upward or downward? It's opening upward. So all we have to do now is find another set of symmetric twins. So here's a really nice, easy point. What's one point that's a half from the axis of symmetry?
One. -1 or 0.
0.
Oh, I didn't find it.
What's 0 plus 4?
4.
What's 0 minus 3?
Negative.
Negative 3. What's 4 times negative 3?
Negative 12.
So that means it's got to be up a little bit more than this one. And there you go. There's your symmetric twin. Done.
Wait, why wasn't it the other one?
Yeah, wait, what's the other one?
These 2 points, 0,
Oh, those
And
are two
1.
different ones.
yeah, 0 and 1 are both 1/2 away from the axis of symmetry.
So that was when X
Oh,
equals
so those
0.
are like the
Yeah.
2 closest points to the.
Doesn't have to be. All I did was chose 0 because it's a lot easier to work with in this case.
So when x equals 0, y was 12.
And then when y was equal, or x equals -1, it would also be equal to -12. Okay? Let me show you. This is the screwballest of them all, is when you're working with intercept form. The rest of them are pretty simple, very straightforward. I mean, vertex form, it tells you where your h and k is. Your axis of symmetry is right there with your x value. Then it's just a matter of getting some symmetric twins via the calculator. When you get into vertex form, you gotta actually do a little bit of math. You gotta figure out what your midpoint is. And then sometimes you wind up with fractional amount, and that's where things can get messy. Let's look at another example of vertex form.
I hope it's not. Oh, it's going -1, going down.
So I have y equals -1 times the quantity x plus 2 times the quantity x minus 1.
Wait, you said we were gonna work with vertex form.
Size. I meant intercept. Sorry, this is the intercept one. I think the intercept out of all three of them, I think intercept is the one that takes the longest to get through.
I was just gonna say.
Yeah.
Why would we do vertex when it's set up for yourself?
Yeah, sorry about that. So in this case again, where are your zeros?
-2 and +1.
Is everybody okay with that? -2 and +1 to get your zeros right away?
Yeah.
Okay. -2, +1. Your
Negative
axis of
1.
symmetry occurs at -1/2. We okay with that?
Yeah.
All right. So let's see. Axis of symmetry equals x equals -1/2. So my vertex, up like a cup, down like a frown. Is it a maximum or a minimum? X coordinate for the vertex is?
0.
Axis of symmetry is always the x coordinate for the vertex, no matter what form you're in. It's always, 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 always. And now it's just a matter of substituting in and or going to your calculator, because if you go to your calculator, you could get some of this stuff, but your decimals might not show with the fractions. You might have to change your tables. So let's see, this is -1/2 plus 2 is 1.5. And then it's times -1.5. -1.5 times -1.5 is 2.25. And it's positive, which is good because it means it's opening downward. So ordered pair at 2.25. I knew it was 2.25 because 15 times 15 is 225. I just moved the decimal over. Sometimes it's easy to work with. Yeah.
I don't know how you got it.
what I did here is I substituted negative half to this. Negative half plus 2 is 1.5. Negative half minus 1 is negative 1.5.
I'm gonna do negative half. Because that's what it's allowed, because it has to be.
Because that's your vertex.
Stupid.
All right. So 2.25, it's about here-ish, and it's a matter of getting your symmetric twins. Once again, in this case here, yes.
No, go ahead. I'll ask.
No, go on.
No, you
Do 0, I
first.
dare you.
Ladies first.
No, you might answer my
That's what
question.
she said.
If I use,
Oh, ooh, right in the
Oh.
You bogus.
if I use 0 in for this, what's 0 plus 2? What's 0 minus 1? So we have negative 1 times 2 times negative 1 gives me
1. No, 2.
2.
Oh.
So at 0 and at
Hey,
negative
one is
1.
also 2, I think.
No.
Kenna, what were you going to ask?
You just, well, I don't know, how do you get the second pair of symmetric twins?
You can go multiple ways. If you find out that you're relatively close to the what do you call it? The y-axis. If you're relatively close to the y-axis, that means you're close to x equaling 0. Use 0 and substitute in. Or use your calculator. Go to the table function.
So you basically do the same thing.
Yeah. If you go to your calculator, it'll show you symmetric twins.
So I don't have to figure it out.
All I'm doing is it's a lot. If you recognize that you're really close to the x-axis, and it's only that one spot away and the other one's one spot away, they're symmetric twins, I can just move those points real quick. Especially working with zeros or ones. Anything that's easy to work with. If it's easier for the type buttons in your calculator, go for it. But all I'm saying is if you can do some of the mental math here by just substituting in 0, sometimes it tends to be a little bit quicker.
Okay, I get
That's
it.
all I'm doing. Okay? Yes, sir.
Does a parabola ever even out so it's straight or does it always?
It always has a little bit of a curve to it, even though it may appear that it's approaching a vertical asymptote, but it will always be an increasing or a decreasing function. Yes, sir.
So
That's a good question.
Possible that it goes like it's coming down. It won't ever like bend back in. At all.
No, then you're dealing with an ellipse, and we're not looking at ellipses until we get into economics. We will. They're fun.
They're so
Fun for you or
compact.
fun for us?
Fun for all.
They're fun for you.
Let me give you a couple. I'm going to give you a whole whopping 6 homework questions.
Come on over.
On page 253.
Wait, should we use our graphic paper?
Yeah, please.
I'll just use the back.
What I would like you to do for these graphs is I want you to give me the vertex. Is it up like a cup, down like a frown? So is that a minimum, a maximum? The axis of symmetry. Well, that's x equals something. The ordered pair. And plot 2 symmetric twins.
You want all that?
It's not that much.
Okay, what
You have to do that to graph them anyway.
What are the actual problems?
Oh, yeah, I should probably give you those. What's that?
You still. You're mad still, Mr. Mark.
22 and 24.
And then 26 to 30.
28, 30, and 34, 36. It's basically what I'm giving you guys here is 2 problems of each style. There's 2 in standard form, 2 in vertex form, and 2 in intercept
You
form.
can't check your answers to see if
No, but you have graphic calculator.
you're
Your mom's graphic calculator.
I don't hear like.
Hey, guys.